Alright, so next we're going to differentiate cotx from first principles. So remember that we're actually going to first let y be equal to cotx. So remember that y represents that cos x can also be expressed as cos x over sine x. So now we're going to introduce the change in y and the change in x. So where there is a y, we introduce a change in y, and where there is an x, we introduce a change in x. So now we can make change in y the subject, and then that's what it's going to be equal to. But remember that y is cos x over sine x. So now this is what we end up having. So now next we're going to find the LCM. So the LCM is sine x sine bracket x plus change in x. So when you get this value here, divide by this, we are left with sine x. So we have sine x multiplying this. So that's what we have. Then when we get this, divide by sine x, we are left with this. So we get sine x plus change in x times cos x, and that's what we have right there. So now we can open up with the knowledge of compound angles. We can actually expound everything in brackets. Then when we simplify and open brackets, we can actually see what happens. So actually this negative affects everything here. So it's going to be a negative, a minus also. Alright, so now next we can actually see that there's some values that cancel. So this and this cancel, and we're left with these values. But remember that for small angles measured in radians, sine change in x is approximately equal to change in x, and cos change in x is approximately equal to 1. So therefore change in y shall be equal to that. So now we can actually factorize out the negative change in x, and inside the brackets we are left with sine squared x plus cos squared x, of which now those are equal to 1 from the knowledge of trigonometry. So we're left with that. So therefore now we can multiply both sides by 1 over change in x to now actually create the slope formula, of which the slope formula is change in y over change in x. So now on the right hand side we're left with a negative 1 over sine squared x plus change in x sine x cos x. So now we're going to approximate to 0. We're going to approximate the change in x and equate it to 0, and then we're going to introduce the dy dx. So therefore dy dx shall be equal to that. So now dy dx is equal to negative 1 over sine squared x, of which that's definitely equal to negative cos x squared x. So therefore the derivative of cot x is negative cos x squared x, and that is what they wanted.